The final homework on the normal approximation to the binomial distribution. Once again, I have my esteemed colleague with me, Griffin. Okay, so he's excited about being here for this. So I'm going to go to the book, and the first part of the homework, numbers 5 through 12, are all about the 0.5 adjustment because people often have a lot of questions and confusions regarding the 0.5 adjustment when you do a normal approximation. Number 5 says the probability of more than 15 people. I'm going to stop right there. More than 15 people. So I want to shade to the right, but I don't want to include 15. So I'm actually going to begin. I have a choice between beginning at 14.5 or 15.5. And if I'm shading to the right and I do not want to include 15 because more than 15 doesn't, I start at 15.5 and shade to the right. That's why I wrote my answer here. Now, that answer is not necessarily the correct way to write it. I just want to show that we're starting at 15.5 and going to the right. Number 12 says at least 12 people. Okay, so I have the choice. Here's 12. I have the choice of starting at 11.5 or 12.5 and shading to the right. But if I want to shade to the right and I want to include 12 this time, because at least 12 includes 12, I know this is horrible writing, I'm going to start at 11.5 and shade to the right. There is no hard and fast rule about the 0.5 adjustment. Mr. Collodi, should I start above the number? Should I start below the number? The answer to that question is you must read the question and ask yourself, A, which way am I shading, to the right or to the left? And B, do I want to include the number or do I not want to include the number? And that's going to tell you which side to shade on. All right, the next question, number 7, says fewer than 12 crying babies. So fewer than 12 means less than 12, so I'm going to start at 11.5. And now I'm going to shade to the left. So that's why I wrote less than 11.5. 27, not really a feasible question because it says the probability of exactly 27 vending machines working in the U.S. If I found this was a binomial question and it was the probability of exactly 27 machines working, I would just use my binomial formula. But if you had to round around or do the 0.5 adjustment around 27, you would go from 26.5 to 27.5. I hope you're beginning to follow along with this right here. Number 9, more than 4 absent students. So since more than 4 does not include 4, wait, I'm sorry. Let me read the question again. Number 9 says no more than 4. All right, so no more than 4 means that here's 4, and I want to shade to the left, but I want to include 4, so I could start at 3.5 or 4.5. No more than 4 means I want to include it, so it's actually 4.5 going to the left. Between 15 and 20 inclusive. That word inclusive is very, very important. Oof. Inclusive is very, very important. Because I want to include 15, I start at 14.5 and start on my path to the right. Because I want to include 20, I end at 20.5 after I pass 20. I hope this is becoming a bit more clear, this 0.5 adjustment concept. All right. So number 11 says between 8 and 10 inclusive. So I start at 7.5 and I end at 10.5. Griffin, does that sound like it makes sense? Yeah. Yes, great. So speaking of the binomial programs on your calculator, pause this video, have your calculator handy. In number 13, n equals 12 and p equals 0.6, and they're asking for the probability of 7 successes. This is a binomial question. This is a binomial formula on your calculator. So you go to the binomial formula. Binomial formula on your calculator. Probability is 0.6, trials is 12, successes is 7, and you'll get 0.227 as an exact answer. If you could use the binomial program, by all means, use it and move along. Don't even bother with the normal approximation. Okay. By the way, and speaking of the normal approximation, Part B in number 13 said use the normal approximation if it's suitable. N times P, well, so right now Q would be 0.4. So N times P is 7.2. N times Q is only 4.8, which is less than or equal to 5. So the approximation is not even suitable here, let alone you wouldn't want to use it anyway. Just use your binomial program. Same thing. Number 15. there's 11 trials, and the probability of success is 0.5, and they want you to find the probability of at least 4 successes. Anytime you have a binomial situation and you want to find the probability of more than 1 success, you use the Binosum program, not the binomial, but the Binosum program. Binosum will spit out the answer to you, 0.887. It is the exact answer to this problem. Once again, that's what I would do if I were you. This is done in seconds and you got the answer, the exact answer. However, part B said use the approximation if you can. So notice that NP and NQ are both greater than or equal to 5. Great. So let's do this. Mu is just n times p. Sigma is root NPQ. You get 1.658. So 5.5, the mean goes right in the middle. I want to find the probability of at least 4 successes. Here's my rectangle right here. But at least 4 includes 4, so I'm going to start at 3.5 and shade to the right. All right, so I plug 3.5 in as a I plug 3.5 in for x into my z-score formula. 3.5 minus 5.5 divided by 1.658, and it gives me this z-score of negative 1.21. I look that up on my z-table, and I get 0.3869. Add that to 0.5, which is to the right of this center line, always, and I get 0.8869. Take a good look. This is a very close approximation, is it not? It is 1/10,000th off. However, it took much longer to get that approximation than it did to get the exact answer. Use Binosum or the binomial formula or binomial program on your calculator whenever you can. Speaking of that, in number 21, you cannot. If you tried to use Binosum on number 21, it would say error overflow. There are more than 400 trials. So P is 0.25, Q is 0.75. I didn't even have to do this test, but sure, they're both greater than or equal to 5. The mean is just n times p. Sigma root NPQ, you get 10.428. The probability said find the probability of getting at least 152 successes. So imagine 152 is right there. I draw a rectangle around 152. I start at 151.5 and shade to the right. All right, that produces a z-score. 151.5 produces a z-score of 0.62. 151.5 minus 145 divided by 10.428. That gives me an area of 0.2324. But look where I put the 0.2324, from the center out to that line. So how do I get my actual answer here? I did 0.5 minus 0.2324. And it produced the answer that you see before you. Remember to subtract from 0.5 if you're ever beginning at a line and going outwards. The last question I'm going to go over, well actually last two, sorry. 23, cell phone use and brain cancer. Again, we've gone over this example a number of times. It keeps coming up in our book. 420,000 trials. No way we can do Binosum here. So the mean is 142.8. Standard deviation 11.949. All right, it says find the probability of getting no more than 135 brain cancer cases. I know that sounds very bleak, but there's 135 right there. Draw your rectangle around it. I started at 135.5 since I want to include 135. Gives me a z-score of negative 0.61, a resulting area of 0.2291. And when I do 0.5 minus 0.2291, I get the answer that I am looking for, 0.2709. Last but not least, listen, 35 is an absolutely interesting question. I'm just not going to have time to go over it on this video because I have less than a minute. All right, but it's a question about Joe DiMaggio, number 35. Read it. Look at my answer and try it. It's one of my favorite questions. But number 26, straight up Binosum, yo. Look at this. There's only 100 trials. Probability is 0.2, and you want to find the probability of greater than or equal to 25 successes. So I would definitely use Binosum here. Probability, 0.2. Trials, 100. High successes, if it's 25 or more, that's 100 then. And low successes, would be 25. Notice I don't do a 0.5 adjustment when I use the binomial programs. Why? Because it's a binomial problem, and I'm using a binomial program. And you get the answer of 1292. Griffin, say bye.
Bye.